Hello student, welcome back to lecture series on Fourier transform. So I already uploaded all the videos based on the Fourier sine, Fourier and Fourier cosine transform along with their inverse transform. So if you are interested to see this video, do check in that I button. You will get all these videos. Okay, in my today's video, I'm gonna explain to you all one of the important property for Fourier transform. Okay, which is a third property, which is a shifting property. Okay, so in my last lecture I explained to you all linearity property, change scale property. Okay, and it is a third property here, shifting property. Okay, so in my today's video I'm gonna explain to you all shifting property in detail with its a proof. Okay, yes, let's get started our today's lecture with a shifting property. Okay, so shifting property we define on a Fourier transform. Okay, so here capital F of s I consider is the complex of Fourier transform, okay, which is of a small f of x. Okay, so capital F of s I consider complex of Fourier transform of small f of x. Okay, yes, and then a shifting property says that what the shifting property says that then we write capital F. Okay, capital F means it is a Fourier transform. Okay, over f small f of x minus a, small f of x minus a. Okay, which is equal to e raised to is a into capital F of s. Okay, yes, now see that this one is our required shifting property. Okay, capital F of over small f of x minus a. Okay, that means Fourier transform over f of x minus a can be written as e raised to is a into Fourier transform over es. Okay, yes, let's get start the proof of this property. So for the proof of a shifting property, we are going to define the definition for Fourier transform here. Okay, as we have Fourier transform f over es, it is given. Okay, which is a complex Fourier transform. So for that we are going to apply the definition of a Fourier transform, and the definition of a Fourier transform, it says that Fourier transform over f of x or Fourier transform over es can be written as minus infinity to plus infinity small f of x e raised to isx dx. Okay, so this one is the actual definition for Fourier transform. Okay, yes, so we have to apply that Fourier transform over here. Okay, so just go for the applying. So instead of f of x we have f of x minus a. Okay, so Fourier transform, I'm going to write here Fourier transform over f of x minus a. Okay, f of x minus a, Fourier transform over x minus a can be written as minus infinity to plus infinity small f of x. It is replaceable by f of x minus a. Now f of x minus a. Okay, this one is a replaceable. Okay, e raised to isx dx here. Okay, yes, so what I have done, I replace f of x as a f of x minus a. Okay, f of x as a f of x minus a and e raised to isx dx as it is here. Okay, yes, now see that in our previous property, change scale property, whenever we have function under function f of ax, okay, then we applied substitution method. That means function under some another function we apply substitution method. Okay, yes, so in this case we are going to do similar concept. Okay, yes, we are going to apply similar concept. That means apply substitution. So substitution means we are going to replace x minus a as a t. Okay, we are going to replace x minus a as a t. Okay, so the value for x minus a we are going to replace as a t here. Okay, yes, so if you are replacing that x minus a as a t, that means you have to replace that x also and that dx also, because this matter for the x. Okay, this matter for the x term. So the value for x can be written using this one. X can be written as x which is equal to a plus t. Okay, so what I have done, I taken that negative a to the other side, we got the plus a over here. So you replace, we got the value for x also. Okay, now let's work for the dx. We have to replace dx also. Okay, yes, so x minus a, if we are going to differentiate this step, okay, we will get the dx. Okay, so x is having differentiation with respect to x, which is 1. Okay, minus a, it is a differentiation 0. The differentiation of a t with respect to x is a dt by dx. Okay, dt by dx. So we want the value for dx only, so take dx here. So we write dx which is equal to dt. Okay, I hope you all have understood how I am substituting the values here. Okay, so I got the x as a plus t, okay, dx as a dt, okay, dx which is equal to dt. Replace all this value in our given integral. So integral over minus infinity to plus infinity, okay, integral over minus infinity to plus infinity, f of x minus a, okay, f of x minus a means f of t, okay, f of t over here, okay, e raised to I s x dx, okay, e raised to I times s. What is the value for x? X is a plus t. Replace a plus t here, okay, a plus t I replace here, okay, e raised to I s into a plus t, okay, and dx also can be written as dt, okay, dx written as a dt over here, okay. Now see that I return Fourier transform over under curly braces x minus a, curly braces complete, minus infinity to infinity, f of t e raised to is into a plus t, okay, this one is a plus t. I'm replacing here a plus t dt over here, okay. Yes, now what we do, we go for the expanding that e to the power, okay, then it is easier to replace the values here, okay. Yes, so keep minus infinity to plus infinity as it is, okay, integral over minus infinity to plus infinity as it is, f of t also as it is, okay, e raised to is into a, okay, e raised to isa, e raised to isa, again e raised to ist, again e raised to ist dt, okay. Yes, so what I have done, let me explain again, okay. Is I multiplied to a, so isa as the power, and is multiplied to t, then ist, okay. So now see that whenever we have base same, we add their power, so e raised to isa plus e raised to ist will get this step, okay. Yes, dt as it is here. Yes, so this step I written this way, okay. Yes, now we have to convert this form into this form, okay. Yes, so we are finding actually this Fourier transform now, which gives us the value e raised to isa into f of s, okay. Now see that with respect to dt, e raised to isa, it is a constant, so if it is constant, take it outside, okay. So I'm taking it outside, e raised to isa integral over minus infinity to plus infinity f of t e raised to ist, e raised to ist dt, okay. This one is a constant outside, this constant term outside here, and under integral I written this one, okay. Now here we can see that it seems like that minus infinity to plus infinity f of t e raised to ist dt, it is the definition for Fourier transform over function yes, okay. So we write f of s, this one, okay. So we are going to write e raised to isa, keep as it is, don't do any changes here. This integral I'm going to write f of s, okay. This integral I'm going to write as a f of s, and so this one is the value for capital Fourier transform over f of x minus a, okay, curly braces complete, okay. I hope you all have understood the Fourier transform over f of x minus a, which is e raised to isa into f of x, okay. So it is not the difficult, guys, it is one of the easier. We are applying just simple substitution over here, okay. This one is the substitution we are taking here, it is one of the easy substitution. So this one is the entire shifting property. I hope you all have understood, guys, okay. Even after, if you found anything difficult, let me know in my comment section, guys, okay. So this one is our required shifting properties, okay. Yes, so in our next lecture we go for the convolution and modulation theorem, okay. So till that you must have to go and revise these terms, okay. Yes, and example based on this topic we'll see it later, okay. Yes, so thank you everyone, thank you for my today's lecture.